Good morning to all and welcome to all the first year student. We are now going to discuss Unit 1 and Chapter 1. Unit 1, that is sets. First chapter is sets. We shall discuss about the sets. Fundamental. What do you mean by sets? How we can represent these sets? What is the cardinality of these sets? Different kind of sets. Also the operation of sets. Then in Unit 1, the subjects are sets, relation, function and trigonometry. First we shall discuss about the set. What do you mean by set? Set is a collection of well-defined objects. Set means the collection of well-defined objects. The collection of well-defined objects is called a set. That is important. Well-defined. Collection of all objects is not a set. Collection of all well-defined object is called a set. What do you mean by well-defined? Well-defined means, for example, all the rivers in India. All the rivers in India. Collection of all rivers in the India. It is a set. If collection of all big rivers in India, it is not a set, because the word big is not defined, well defined. Why in which way the rivers are big, either in length or in width, it is not well defined. So it is not a set, but this is a set. Suppose all the student in your class is a set, but all the good student in your classroom is not a set, because the word good is not well defined. The collection of well defined objects is called a set. Suppose collection of all towns in Odisha. All town in Odisha. It is a set. But if we write collection of all big towns in Odisha, it is not a set, because the word big is not well defined. So collection of all well defined means if there is an adjective, that must be well defined, other it is not a set. All the trees in Odisha is a set, but all big trees in Odisha is not a set. All the players is a set, but all good players is not a set. Means if there is a uses in adjective, that must be well defined, otherwise it is not a set. Set means the collection of well defined object is a set. That is, the collection of well defined means if I take collection of all big towns in Odisha whose population is more than 20 lakhs, it is a set, because why it is big, it is well defined. So the adjective must be well defined, then it will be set. Suppose collection of all real numbers, collection of all real numbers with negative square, with negative square. It is a set. There is no real numbers whose square is negative, but it is a set, but it is called null set, or that is void set, but it is a set. Collection of all winged horses is a set. Collection of all college teachers is a set, but collection of all good college teachers is not a set. Collection of all human beings is a set, but collection of all wise men in world is not a set. So the collection of well defined object is called a set. Then how we represent a set? How we can represent a set? A set can be represent in two different ways. In two different ways. A set can be represented in two different ways. One is set builder form. Set builder form, or it is also in other way specification form. Specification form or intention form. Intention form, that is, a set can be represented in two different ways. One is set builder form and another is roster form. Roster form, or that is tabular form. Tabular form or form of lists. Form of lists. We can represent or describe in two different ways. One is set builder form and another is roster form, that is tabular form or form of list. We shall discuss some examples so that how we can represent a set, it will be clear. Suppose collection of all natural number. Collection of all natural number. It is a set and we can describe in two different ways. Suppose in roster form it is written as 1, 2, 3, 4 ... This is the roster form or form of list of the natural number. But in set builder form it is written as x such that x is a natural number. X is a natural number. So a set can be described in two different. One is roster form or that is form of list, and another is set builder form or that is specification form or that is intention form. For example, suppose a set is x belongs to n such that x square minus 1 equals to 0. This is the specification form or set builder form of the set. We can convert to roster form, that is only 1, because if x square minus 1 is equal to 0, then x square will be 1 and x will be plus or minus 1, but minus 1 is not in set n, so only 1 is set n, so its rooster form is only 1. That is the set builder form and this is the rooster form. Suppose a set A 1, 3, 9, 27. This is the rooster form of this set. This is the rooster form of this set. We can convert this set into set builder form. X such that x equals to 3 to the power n, n equals to 0, 1, 2, 3. This is the set builder form of this set. If we take 0, 3 to the power 0 is 1. If we take 1, 3 to the power 1 is 3. If we take 2, 3 to the power 2 is 9. If we take 3, 3 to the power 3 is 27. This is the rooster form, this is the set build form. So we can write a set builder form to rooster form, also rooster form to set builder form. Suppose this set is 1 by 2, 2 by 3, 3 by 4, 4 by 5, dot dot dot. This is the rooster form of this set. We can write in set builder form as x such that x equals to n by n plus 1, where n belongs to n. This is the set builder form of this set. So we can describe its set in two different ways. One is set builder form and another is rooster form. So we can convert rooster form to set builder form, set builder form to rooster form. This is the description of a set. So a set can be described in two different ways. One is rooster form, another is set builder form. Next, cardinality of a set. Cardinality number. What is the cardinality number of a set? The number of distinct elements present in a set is known as the cardinality number of a set. Suppose a set contain element 1, 2, 3. Here this set A has three distinct element. So the cardinality of set A is 3, or order of A is 3, or number of elements in A is 3. That is the cardinality number of a set. Means the number of distinct elements present in a set is known as the cardinality number of a set. The number of distinct elements present in a set is the cardinality of set A. We denoted it as A mod or order of A or n of A. That is the cardinality of A or order of A or number of elements in A. That is the number of distinct elements present in the set. Suppose set A contain element x belongs to R such that x square plus 1 is 0. This is the set builder form of this set. So the cardinality of set A is 0 because there is no real number which satisfy the x square plus 1 equals to 0. So the number of elements of this set is null, means A is a empty set. So A is a phi set, that is A is a phi set. So there is no real number which will satisfy x square plus 1 is 0. So the cardinality of set A is 0. So A mod is 0, means the number of element in set A is 0. If the cardinality is 0, then it is called a null set. This is a null set or void set or empty set. Void set or empty set. The cardinality of a set, if the cardinality of a set A is 0, then it is called a null set or void set or empty set. So the number of distinct element, suppose set B contains the element A bracket A B bracket. Here the number of elements in this set is 3. A is 1, bracket A is another element, A below bracket is another element. So there are three distinct elements in set B. So cardinality of B is here 3. So the cardinality of B is 3. The number of distinct elements present in a set is the cardinality of the set. Next, empty set or void set. A set whose cardinality number is 0 is called a null set or void set or empty set. We denoted it as phi or simple bracket. That is the null set or void set or empty set. For example, suppose B contains x belongs to Z such that 2x plus 1 is 0. There is no integer. Z set means set of integer. We denote the set of natural number as n set. Set of integer, that is whole number, as Z set. Set of rational number as q set. Set of irrational number as q prime set. And set of real number as r set. In mathematics, we use this letter as our number system. N set means the set of natural number. Z set means the set of whole number, either positive or negative, whole number. Q set means set of rational number, 1 by 2, 3 by 5, that is rational number. Q prime means set of irrational number, that is root 2, root 3, root 5, that is the set of irrational number. And then all union of all this number system is denoted as real number, that is real number. And we use following notation for the number system. So here x belongs to Z, but 2x plus 1 is 0. So there is no integer which will satisfy 2x plus 1 is 0. So the cardinality of B is here 0. So B is a null set. So that is the set builder form is x such that x not equal to x. This is the set builder form of a null set. A null set can be expressed in set builder form as x such that x not equal to x. This is all about the null set. Collection of all winged horses, set of all boys reading in the women's college. This is also example of null set. All the flying fishes, also example of null set. Next, singleton set. Singleton set. A set whose cardinality number, a set whose cardinality number is 1, whose cardinality number is 1 is called a singleton set. A set whose cardinality number is 1 is called a singleton set. For example, suppose A is contain element A. Here the cardinality of set A is 1. So this is a singleton set. Means a set containing only one element, a single element, is called a null set. Suppose B contains element bracket A. This is also example of a singleton set because the cardinality of B is 1 and it contains the element bracket A. So cardinality of B is 1. So this is also example of a singleton set. Singleton set. Next, subset. Subsets. Let A and B are any two sets. Let A and B are any two sets. If each and every elements of A are in B, if each and every elements of A are in B, then we say A is subset of set B. Then we say A is subset of B. In Venn diagram we represent as this is set A and this is set B. Here A is subset of set B because all the elements of set A are in set B. So A is subset of B. We denoted it as A subset B. This symbol is used for subset of. A is subset of B. In this case we say B is superset of A. That is B contained A. This is superset, this is subset. For example, N set is subset of Z set, Z set is subset of Q set, Q set is subset of R set. This is the example of a subset. All the natural number are in Z set, all the integer are in Q set, and all elements of Q set are also in R set. That is the example of a subset. Suppose A contains element 1, 2, 3 ... That is set A, and B contains the element 1, 3, 5, 7, 9 ... Here B is subset of A. Here B is subset of A because all the elements of B are in set A. So B is subset of set A. Basic things. Suppose set A contains x such that x is a prime number. X is a prime number. And B is x such that x is a natural number. X is a natural number. Here A is subset of B. Prime number means 2, 3, 5, 7, 11, ... These are all prime numbers. And set B contains all natural number 1, 2, 3, 4, 5, 6 like that. So all the elements of set A are in set B. So here A is subset of B. Here A is subset of B. So if all the elements of set A are in set B, then we say that A is subset of set B. Then proper subset. Proper subset. Suppose A contains element 1, 2, 3. Then phi is proper subset of A, because phi is subset of every set. Null set is subset of every set, and each set is subset of itself. We know that null set is subset of every set and each set is subset of itself. Phi is a subset of A and phi is a proper subset of A. 1. This is also subset of set A. 2. This is also a subset of set A. 3. This is also a subset of set A. 1, 2. This is also a subset of set A. 1, 3. 2, 3. These are all proper subset of set A. These are all proper subset of set A. But 1, 2, 3 is not proper subset of set A, because this set is equal to this set. So it is not proper subset. But these are all proper subset. Proper subset, but a subset which is equal to itself is not a proper subset. That these are all 7 are proper subset, but this set is only subset of set A. That is the basic difference between proper subset and subset. Then power set. Power set. Let A be any set, then power set of A denoted as P of A. That is, we call it power set of a set A. That is power set of a set A. That is, power set means X such that X is a subset of A. That means the collection of all subset of set A is called power set. Collection of all subset of set A is called power set. Suppose set A contains element 1, 2. Then its subset are phi 1, 2 and 1, 2. These 4 are subset of set A. Then power set of A is collection of all subset of set A. So here the cardinality of A is 2, but the cardinality of power set of A is 4. That is 2 to the power 2. This is the power set or collection of all subset of a set A. In general, if cardinality of A is n, then power set cardinality of power set of A is 2 to the power n. That subsets of set A. Number of subsets of a set A, that is known as power set of a set A. That is power set or number of subsets of a set A. Suppose a set A equals to 5, then its power set will be bracket 5. Its cardinality is 0, but its cardinality is 1. So here the cardinality of A is 0, but here power set of A cardinality is 1, means 2 to the power 0. That is the power set. If A equals to bracket 5, here the cardinality of A is 1, but the power set of A is 5 bracket 5. So its cardinality is 1, 2, 2, that is 2 to the power 1. So in general, if A cardinality n, then power set of A cardinality 2 to the power n. Suppose A equals to 5, then power set of A cardinality is, that is, here cardinality of A is 0. So power set of A cardinality is 1. Then again if we take power set, then its cardinality will be 2 to the power 1, that is 2. If we take power set of A, then its cardinality will be 2 to the power 2, 4. So similarly we can calculate the number of elements of a power set. This all about the power set. Then next, finite and infinite set. Finite and infinite set. Finite set and infinite set. A set is said to be finite if its cardinality number is a finite number. Suppose all the human beings is a finite set. All the boys reading in a particular classroom is a finite set. Collection of all players is a finite set. All the stars in the sky is a infinite set. So a set is said to be finite if it is either empty. Every empty set is finite, so either it is empty or one-to-one correspondence with the set 1, 2, 3 ... n. A set is said to be finite, either it is empty or one-to-one correspondence with this set, then it is said to be finite set. Otherwise it is said to be infinite set. It is said to be infinite set. A set is said to be finite if either it is empty or one-to-one correspondence with the set 1, 2, 3 up to n. Then it will be finite, otherwise it is said to be infinite set. Suppose n set, this is a infinite set. Q set is also infinite set. Z set, infinite set. Q prime, infinite set. Real number, infinite set. All the even number is also infinite set. All the odd number is also infinite set. All the prime number is also infinite set. So a set whose cardinality is countable means a finite number is a finite set, otherwise it is said to be infinite set. Suppose set A contain element 1 2 1 2 1 2 dot dot dot. This is not a infinite set because its cardinality is 2, so it is a finite set. If we take as -1 to the power n, then it will be -1 1 -1 1. This is also a finite set. This is not an infinite set. But if we take as 2 to the power n, means first n belongs to Z set or n set, then the element will be 2 4 8 dot dot dot. This is example of infinite set. If the cardinality number is finite, then it will be finite set, otherwise it is said to be infinite set. So we can easily find whether this set is finite or infinite. This all about the fundamental of set. You can go to your textbook and complete one exercise, that is the fundamental of sets. Next class we will discuss about the set operations. Thank you all.